सो हे एवरीवन, वेलकम बैक टू ptscadexpert। अगर आप रेविट यूजर हैं तो डेफिनेटली इस तरह के 3D टाइल्स और स्लॉपिंग रूफ बनाने में आपको बहुत प्रॉब्लम्स आती होंगी और मोस्ट ऑफ पीपल आर नॉट अवेयर दैट हाउ टू मेक सच टाइप्स ऑफ स्लॉपिंग रूफ इनसाइड रेविट। तो आज के इस वीडियो के अंदर हम सीखेंगे कि ये जो 3D टाइल्स हैं, अगर इस तरह की लुक में आपको रूफ बनानी है रेविट के अंदर तो कैसे बना सकते हैं। हम इसके अंदर देखेंगे जो टेक्निकल साइड है कि क्या क्या चीज़ें जब आप 3D रूफ बनाते हैं और स्पेशली इस तरह की 3D रूफ बनाते हैं तो उसके अंदर किस तरह से हम बेस डिफाइन करेंगे, बाइंडर डिफाइन करेंगे, किस तरीके से हम पर्लिन, बैटर्न, राफ्टर, रिज बोर्ड, टाई, स्ट्रट, हैंगर, बीम, तो इस तरह की जितने भी टेक्निकल एस्पेक्ट है उनको किस तरह से क्रिएट करना है। तो इसके लिए हम यूज करने वाले हैं फैमिलीज का और पैरामेट्रिक मॉडलिंग का। कौन कौन सी वो फाइल है जिसके थ्रू आप इन पैरामीटर्स को डिजाइन कर सकते हैं। तो स्टेप बाय स्टेप हम सीखने वाले हैं सारी चीजें और रेविट के अंदर कुछ इस तरीके से ये प्रॉपर डिजाइन बन के रेडी होगा जब ये वीडियो आप पूरा देख लेंगे। तो सबसे पहले अगर आप रेविट में स्पेशलिस्ट बनना चाहते हैं, BIM एक्सपर्ट बनना चाहते हैं, तो ये वीडियो आपको लास्ट तक देखना पड़ेगा और एक एक टेक्निकल डिटेल्स और एक एक टेक्निकल एस्पेक्ट को आपको सीखना पड़ेगा। तो ये सारी चीजें बहुत ही डिटेल में इसमें कवर की गई हैं और अगर मैं इसका एक एक्सप्लोर्ड व्यू आपको दिखाऊं तो इस तरीके से ये सारे स्टेप बाय स्टेप इस वीडियो के अंदर हम आपको कवर करने वाले हैं, डिटेल में बताने वाले हैं, जो कि अपने आप में बहुत ही यूनिक एक्सपीरियंस रहेगा अगर ये पूरा ट्यूटोरियल आप देख लेते हैं। और इस तरीके से हम 3D एनवायरनमेंट के अंदर रेविट के अंदर काम करेंगे। और अगर रेविट के अंदर आप एक्सपर्ट बनना चाहते हैं तो आप हमारा प्रोफेशनल कोर्स मास्टर डिप्लोमा इन रेविट BIM जरूर चेकआउट कर सकते हैं। इस कोर्स का लिंक आपको डिस्क्रिप्शन में मिल जाएगा। स्पेशली इंडस्ट्री प्रोफेशनल्स के साथ किस तरीके से BIM के डिफरेंट एस्पेक्ट पे काम किया जाता है, ये सारी चीजें इस ट्रेनिंग के अंदर बहुत ही डिटेल में कवर करते हैं। लगभग 4 to 6 मंथ की ट्रेनिंग रहती है, लाइव ट्रेनिंग रहती है। इसकी सारी डिटेल्स आपको डिस्क्रिप्शन में मिल जाएगी, यू कैन check over there. So without getting late, let's get started.
Hey, what's up, guys? Greetings of the day to viewers of this video, and welcome back to ptscadexpert and myself, Architect Kumar Kapadia from the city of Surat in Gujarat. And for this course, Master Diploma in Revit BIM, which is the combo of architecture plus structure plus MEP for architectural segment. Today's session is going to be all about this typical sloping roof with all its associated 3D components. For example, if you just see that this is the simple hip roof and this is the gable roof, but that has been designed with all its 3D components, wherein you see that this is the truss system and this are the actual 3D roof tiles, which are not the JPEG images. Fine. To make you explain this better, I would just like to take you to this particular image, which shows the hierarchy of elements for a typical sloping roof, which says that the wall is supported with the wall plates, and then we have this joist or this binders and with the truss system depending upon the structural consideration, which is then followed by the layer of purlins, and then we have this common rafters and this hip or valley rafters. Fine. So this is going to be the configuration, and finally on the top we have the battens, which will take the actual roof tiles. Okay, so we are going to design all of this in 3D today, and I have already designed that particular thing, and this cross section displays that particular thing, that we have the wall plates, then we have the truss, we have the purlins, we have the common rafters, and this the grid members and the battens which are supporting this actual 3D roof tiles. Okay, and this is the exploded view of that particular thing which we are going to design today in Revit from scratch. Also, I would like to take you to this particular 3D, which shows the designing of this particular 3D roof, this sloping roof, which has this unequal pitch on both the sides. But and this is nothing, but this is just, if you guys go to PTSCAD app on YouTube, then under this playlist Revit BIM, this entire tutorial has been published, the house villa design, wherein I have been showing you that how to design this particular roof. But what I have just discovered while designing this particular two roof, that there is a flaw with this, a simple glitch, wherein if you just see, then for this project the roofs that have been designed has this roof tiles which are not reaching up to this particular ridge board. Okay, fine. So that is a small glitch, and I'll just explain you by the end of this video that how to rectify this particular thing. Fine. But before that, I'm just going to show you the basics of this particular thing, and also that tutorial doesn't displays the designing of this 3D roof tiles and this ridge, this valley tiles and this ridge member tiles. Okay, so all of that I'm going to show you from scratch, wherein we are going to make use of different template files. Okay, so we are going to start in a fresh new file, wherein I'm just going to say that wall and level 1 and top constraint level 2 and finish face exterior, and I'll just draw a simple small cube, and I'll just select that and make a copy of that. Fine. Okay, and I'll just go to this architecture roof and roof by footprints and place on level 2. Yes, fine. And with this overhang of 2 feet, I'm just going to create one simple hip roof. Fine. And that has been created. Okay. And why is it showing two of them? Delete. Yeah, fine. That's okay. Okay. So now we are going to design step by step all the members. Fine. So as per this image, the first member that will follow as the wall plate. Okay, all these steps are clearly demonstrated in this particular tutorial also, but there was a small glitch which I just said, which we are going to rectify today, and it will be a quick revision. Fine. So just follow, and I'll just go to level 1. And first thing is that, no, not level 1, level 2. And first is that we are going to lay the wall plates on this particular 4 walls. Fine. So for that, I'm just going to go to structure and beam. And right now you see that by default, no beams are provided. So I'll just go to load family, and herein I'll just go to RVT 2024 and libraries, English Imperial. And if you have properly extracted your library, then you should find this folder which reads that structural framing. Fine, this is the structural framing. And for this exercise, we are going to use this wood members. Okay, you can use anything, the process remains the same, the modeling process remains the same, whether it is concrete, RCC, or it is steel, aluminum, or anything. But we are, for today's exercise, we are just going to use this timber. Okay, fine. And I'll just going to open, and I'll just load this particular simple family, beam family. And now if you just go to this family section and expand it, then under structural framing, you would have loaded that timber beam structural framing. Okay, fine, which read that 5x5, and just go to right click and edit type and open up that template file. Okay, and herein I'm just going to go to family types and make a small change, wherein I'm just going to make this structural element, which is right now, it is an instance parameter. I'm just going to make it a type parameter. The reason being, I'll explain you while the modeling, when we will start the modeling part, why I need to change it into the type property and not the instance property. I'll just explain you, so just try to follow. Fine. And right now it has this 5x5. I'll just rename that and call it 4x6. 4 inch cross 6 inch. And for this exercise, all the dimensions and all the structural considerations taken will be pretty much basic and conventional, and that might vary from designer to designer. But only motive of this exercise is just to show you the modeling process. Fine. So here I'm just going to say that breadth should be 4 inch and the depth should be 6 inch. Okay. So with that, apply and OK. Fine. And just load that back into the project and overwrite existing version. And while going into this template file, just close this and don't save it, or else you will end up making changes with the system template file. Okay. So herein now, if you just expand this, then you have two types, 4x6. I will just delete this particular type, and I will just rename this guy, calling it wall plates. I would just like to be specific because we are going to define a lot of them. We are going to design a lot of members, lot of different members within this one family. So I would just like to be specific. Okay, fine. And just I'm going to drag this particular beam and snap to the center of this 1 to 2. And I guess that has not snapped properly. Okay, let me just hide this particular roof and drag it from here to here, from here to here, and all of them Okay, and let's just go to 3D. Fine. And you can see that the wall plates has been laid on the periphery or all that particular walls. Select all of them SA and just change this Z justification to bottom, and that will elevate all that four members properly. Fine. And HR. Okay. Now, in order to visualize that, I'll just select this particular group roof and go to right click and override graphics in view by elements, and I'll just change this transparency to something like 70. Okay, and you can visualize what is happening. You can have a see-through, and you can visualize that what is happening below. Let's just change this bit more. Override view and elements, and oh, 20, not 20, 70, and okay. Yeah, fine. Okay, so the next now the next will be the ridge member and the hip and the valley rafters. Fine. So I'm just going to make a duplicate of this. Go to type properties and just duplicate this and call this ridge member or ridge board. Okay, and this should according 18 inches. Fine. And the depth should be 18 inches. As I said, all the dimensions and everything will be pretty much basic and conventional. You can change it according to your design. And herein this will be 15 inches, which will be the valley rafters. Okay, and here too I'm just going to change this to 15 inches. Okay, and one more, which will be the size will be same, but those will be common rafters. Okay, and valley rafters, rename and rafters. Yeah, okay, fine, apply and okay, that's okay. So now the four different types has been defined within this one single family. Okay, so what I'm going to do is that first is that we are going to lay this ridge board. Just drag and drop, and with 3D snapping on, very important, just snap to the uppermost point and here. Okay, so that member has been laid. Fine. Now this next will be the valley rafters. So just drag and drop, select this point and select this point and this topmost point. Okay, so that has been laid. From here, I will just select this. Okay, and from here to here, yes, and this to this. Okay, so all the ridge member and the valley rafters has been laid, but we need a differentiation. So what the reason of changing that material part into a type parameter, I'll just come into it. So I'll just select all of this SA and change this Z justification to bottom, and also this Z justification to bottom. Okay. So the reason was that I wanted to define a different material for all of this so we can have a differentiation. Fine. So I will just go to the particular ridge member, edit type, and you can see that now we can assign a different material to this. And I'll just open up that material dialog box. And from here in, I'll just open up wood. I'll just type in wood. So I'm just going to copy few of the existing materials by Revit, defined by Revit, which we are going to use for this particular modeling purpose. And okay. And here in this material, I'm just going to use for that ridge member, apply and okay. Fine. Also for this valley rafters, I'm again going to use that same dark material that we just loaded. Okay. And apply and okay. So you see that if I just change this to realistic, then it has changed that material to the one that we just selected. Fine. With this, now I'm just going to take this a bit until it snaps to that particular point. Okay. And yes, just take this a little bit. Okay. And just select this two, and drag it. Yes. And this two up till this point. Fine. Okay. Now, if you want to have a perfect connection, then what method you need to follow? I'll just show you once we lay that particular common rafters. Okay, I'll just show you. So with this, I'll just turn on HR and CC again. Now what we are going to do is that this is the roof, which is having a thickness of 12 inch. Okay. But we are going to use this roof as a reference to lay the different members of that particular typical roof. Okay. So here is the point that comes the glitch which I was talking about, which was made while designing this particular thing, and the reason why do we don't have this particular uh, roof tiles reaching up to this particular ridge member. I'll just explain you that. Okay. So the reason was that for defining this particular common rafters, what system I need to follow is that I need to go to structure and we will define a beam system. BS is the shortcut. For that, essentially, I need to set plane. Okay. And under that set plane, pick a plane. And what I did earlier was that used to select this bottom plane. But with that selected, that will not lay those members properly. And in order to lay that properly, those members, in order to visualize, lay that members properly, you need to select this top plane. Okay. And just select that particular plane and define a beam system. And beam system, and I'll just turn it to HL so we can visualize those lines. And herein, I will just create those system 1, 2, and 3, and 4. Okay. And now, very important is that to define the beam direction. Okay. So herein, I will just select this particular beam direction line. And from the center, you can click anywhere. But what is that? You need exact that perpendicular line defining that particular direction. And you see that this dotted line, this dotted gizmo says that this line is now exactly perpendicular. Okay. And with that, I'll just go to edit type of this and again duplicate this, calling it structural framing system common rafters. Okay. Rafters. I just like to be specific and perfect. Okay. Common rafters. And for that, what I'm going to do is that fixed distance, I'm going to call it 2 feet. But for the beam type, I will just drop down and we already have defined that different type common rafters, which I'm going to use. Okay. And just hit the checkbox. Fine. So with that, all the common rafters has been laid. Okay. I'll just turn on CC. Okay. So here is that. And we have just this two small members, which I'll just unpin depending upon the, let me just change this to 25 inch. And yeah, changing it to 25 inch will just get rid of that particular member. Or else what you can do is that you can just select this particular one member, unpin and delete it. But instead, let's use a different size. Okay. Because size may vary. So now what you see is that now this particular common rafters are reaching up to the top ridge member, which in this case, they are not reaching. Okay. If I just H and you see that this particular ridge members are stopping here and not reaching up to this ridge member. So the only flaw or the only glitch was defining the work plane, which is very important in Revit. Now what I'll do is that I'll select one of them. I'll just go to edit type and herein I'll just define a different material, existing material sash. Okay. For that particular common rafters. What is the next step? The next step is that now we used to define the purlins. Okay. Actually, we were supposed to lay the purlins first. Yeah, that's fine. Okay. I'll select all of them and just HH, and also I will select this beam system and say HH. Okay. Now the purlins that we are going to lay, which will be supporting this ridge member, this particular purlins. These are the purlins. See, those are going to be laid on the bottom of that rafter. So in this case, what we are going to do is that we are going to set pick a plane, and now the work plane that we select are going to select this bottom work plane. Okay. And I'll just select this bottom work plane and beam system and edit type and duplicate, and this are going to be purlins. The reason of duplicating and renaming it and creating every time this particular structural system is that will help in modeling part later. Fine. So you will just witness this. I'm just going to change the spacing to 3 foot and change this to we don't have the type defined. So again, I'm just going to duplicate this type properties, duplicate, and this is going to be 6 cross 4, 6 cross 4, and those are going to be purlins. Okay, and I'll just reverse this dimension and depth to be 4 inches. Okay, and for the material, I'm just going to define existing material that we have just loaded. Yes, birch. I want this not glossy, but this simple birch. Okay, and apply and okay, apply and okay. Fine. And now with this, for this particular thing, now that since that particular purlin has been defined, I can use those purlins for this particular beam system, but why is not allowing to? Yeah, fine. You just need to click in this particular space and beam type and get out of the command. Okay, and beam type and just drop down and yes, timber 6 cross 4 purlins. Okay, and with a distance of 3 inch and very important, the beam direction. The beam direction, no, but first we need to draft the boundary lines. The boundary lines is going to be the bottom plane that we selected. Okay, and the beam system and the boundary and the beam direction. Yeah, this is the proper. Actually, you can just snap it until the dotted line pops up showing that it's perfectly perpendicular to this plane. Okay, and just hit the checkbox. Fine. So your purlins has been laid properly. Only thing that you need to press HR and just check here. And what you notice that here there is a problem wherein the last purlin, I guess, is getting. So let's go to level 2 and change this to fine. Okay, and just drop a section HH and yeah. So see here there is a problem. Okay, so just select this particular thing and change the spacing. Let's say that 4 feet. Okay, and it's absolutely perfect. Okay, so the purlins has been laid, the ridge member has been laid, the common and the valley rafters has been laid. Fine, and R enter. Yeah, fine. So we have a differentiation. Okay, but when you lay this again, you need to properly associate this particular thing, and I guess that this particular bottom and it snap to this point. Yeah, fine. And select this and join this to this as well. Okay. Now is the point wherein we need to have a clean joint. Of course, the machine will adjust it on site. But since we are talking about the modeling part and modeling concepts, then I would like the things to appear perfect. And right now you can see that the things are overlapping. Okay, and the members are overlapping and getting inserted one within the another. So what is the trick in this case is that you need to select this very powerful command, very important command, notch. Okay, and notch and select that individual members and select the member which you want to create the notch joint with. Okay, and let's check it for one. And if you just drop this down, then you have this notch distance, which I'm just going to change to 0. And yeah, but no, that is not still properly. Let's just try it for this 0. I guess that is, let's just HH and hide this particular roof and notch. Select this and this. Why is it not? Yeah, the notch has been created, but since it's, yeah, since because of its uh, The notch has been created, but because of its the way it has been laid, it is not creating a clean joint. Fine. When we will lay this particular this members, then we will understand that what needs to be done. Okay. So just HR, and now for this particular thing, this face, I'm just going to create those both. That is this purlins and this common rafters. Actually, it should create a notch joint. Why is it not? Okay, fine. Let's not waste time on that and let's proceed on with the modeling part. Okay, and again, I'm just going to HI and select this roof. Isolate this roof and go to structure and set plane and pick a plane. And this time I'm just going to select this top plane. But let's lay the purlins first. So pick a plane and the bottom plane. Okay, and bottom plane and just go to beam system and we already defined that purlins. Okay, HL and just draw those four lines, 1 to 2, 3 and 4. Okay, and say that the beam direction should be from here to this. Okay, and rest all the properties same. That is the fixed distance, but I guess that we use 4 feet for that. Okay, and HR, is that corresponding? Yeah, see, this is exactly perfect. Okay, and we have, if I just go take you to this particular top view, then you see that the connection follows. Fine. Okay. Now the next is that we have to define, again select CC and that roof tab. Yes, tab until you select that particular roof and isolate it again and go to set plane and pick a plane. And this time, since we are going to lay the common rafter, I'm going to select this particular plane and go to beam type. Oh, sorry, not beam type, beam system, and just drop down and select this common rafters. Okay. And the moment you select it, since this is an instance parameter, so you have to change it from here also and just change this to common rafters and the fixed distance should be 2 feet. Okay. And I'll just draw a line 1, 2, 3, and 4. And the beam direction should be essentially this. Okay. And 2 feet distance, 4 cross 15 common rafters, everything is perfect. Hit the checkbox. Okay. And now turn on this. Okay, so now it is very important to have a proper connection. And yes, in order to make this particular connection appear properly, let's just try that same command, that is notch this to this. Yeah, see, and this to this. But again, this is, yes, and problem, I guess that something is the problem here, which we need to figure out. And for that, if I just take you to this particular, yeah, let's go to this section and let's turn this to fine. And okay, yes, the common rafters which has been laid. Let's turn on this roof profile, HH, and this is the roof. Okay, and these are the rafters. Okay, so yeah, see, uh, the thickness of that particular roof is 12 inch. Okay, and but for this particular rafters, let me turn on to CC and no wireframe. Yeah, the common rafter that we have laid, edit type, and you see that its depth is 15 inches. So we actually need to flush this in order to have a notch connection. We essentially need to notch this, and you see there is a 3 inch of difference, 3 inches of a difference. Okay, so that is the reason. And also one more thing, if you just select this particular beam system, this particular beam system of common rafters on top, which is exactly on the top, let me just, yeah, if you select this, then the fixed spacing distance is 2 feet 1 inches. So that same should pertain here. Okay, so what I will do is that I will just press tab until I select this beam system and say that the distance, fixed distance should be 25 inch. Okay, yeah, remove notching. Okay, fine for now. And that will flush. At the same time, select one SA that will select all this particular common rafters, and the Z offset value with Z justification to top, the Z offset value should be 3 inches. Okay, and with that, now if you just see, then that connection is flushed. Okay, and the extrusion that we have is on this face. Okay, 3 inches. Yeah, fine. So now with this, if I just go to 3D and if I just hide this particular roof, and then now if I just apply notching to this with notching distance to 0, and this also, let's try it for all these members. Notch 1 to 2. Yeah, fine. And with that, you see that we have the perfect flush connection that we wanted, and you have to do it for all the members. And let's check whether, yeah, okay, okay, and then select the peripheral members which are connecting with this valley rafter, and with that all of them selected, just change this notching distance to 0. Okay, and with that, now if you just check in top level, okay, and we have a flush connection. Okay, so that is how one step you perform wrong, and then okay, so with this now you see that we need to notch this as well. So notch this member with here, yeah, fine, and likewise notch all of this to this valley rafter, and just drag it a bit. Okay, and select both of them and say that the notch distance should be 0. Okay, and that will perfectly join. Okay, likewise here too. See, if I just select all of this, 1, 2, and all of that will now perfectly create a flush connection. Okay, and with that selected, with all those members selected, just change this notching distance to 0. And at the same time, we need to apply the notch joint here as well. But let me just drag it a bit here, and this should follow. Irrespective of this, the machine will follow the conventional method and join this. But since we are talking about the modeling part, so that's why I'm so much. Yes, and notch this to this as well. Notch, and yes, we need to drag it a little bit. Okay, and just select both of this and 0. Fine, and we have a clean joint. Fine. So now the next step follows is that as per that particular image, we have laid this particular rafters. Now the next is that we need to create this battens. Okay, after this particular rafter, we have this battens. Fine. So for that, what we are going to do is that we are just going to select this uh, perlins and this system, both of this structural system perlins. Okay, and just copy it to clipboard and use the drafting skills with Revit. Align to same place. That will make a copy of those perlins on that same place. There are identical instances. Fine. What we just need to do is that just change those two. Again, define a different system and call it battens. Okay. And with that, you also need to change that here in instance property, wherein right now it is reading perlins. So you again need to define a new type of this. So go to type properties, duplicate this and call it 1.5 cross 1 inch. And that should be battens. Exit size you can decide 1.5 inch. 1.5 inch cross 1 inch. Okay, and this should be material should be bamboo. Okay, so we'll just have a differentiation. Okay, and with that, just click in the space, and where is that? Yeah, batons. And with that selected, just change this particular type to batons. Okay, so with that, the thing is done. So those batons has been created, but they are right now at wrong work plane. And yes, also the fixed distance, the fixed spacing should be only 15 inch. So you will have, okay. Likewise, also need to select this batons and change this fixed distance. All of this are instance properties, so you need to change instantly for all of them and change this to batons. Okay. With this, now just go to section 1 and select SA. So all of that will be selected. Just press move, and with this join, yeah, but those might have selected the batons on this side also. So just do one thing, SA, and batons have been selected. Just deselect this, the one on this face, and go to section 1. And with that, now you'll be able to move this and this join, and still not. Why is it not snapping? Move, and why is it not selecting? SA, and let's go to top, and let's just deselect this. Also, let's deselect this. I guess there is a problem over here. Let's just redo this part. Okay, let's just do it, compute it for this phase first. Okay, so let this system be there, buttons. Okay, and from here in, I will just select all of them SA. So the one created on this phrase has been selected, and move and constrain, and yeah, see, now the snap point is coming, which earlier was not coming. So you need to be very particular. M enter and constrain uncheck, and with this join check, just move it from this face to face way, and I hope that this should have laid it properly, perfectly. Okay, fine. So that has been laid. Okay, you need to get rid of this extras, delete, and fine. Now we will select this bottom, the pattern that we created on this face, and change this distance, fixed distance to 15 inches, and this to patterns. Okay, so that has been created, but what we need to do is that we need to properly SA and just deselect all of this. And with that selected, if you just go to section 1, you cannot visualize it because that is the vertical section. You need to draw a horizontal section. Go to that particular section. Fine. So we can visualize those patterns. And now again coming to 3D, I'm just going to select one of them, SA. Shortcut is SA. That will select all of them. And with that, just go to section 2. And with all that selected, just move and move it. And with constraint uncheck and disjoint check, with move it from this point to this point. Once again, why is that doing 2 times? Yeah, fine. Okay. So that has been done. And if I just change this to fine, oh, sorry, just press undo and just turn it to fine. And again, coming to 3D, select all of them, SA, and deselect them. We snapped it to wrong face and move enter, M enter, and with constraint unchecked, constraint unchecked and disjoint check, just move it and fine. That has perfectly moved it in place. Okay. And just get rid of this one element. You don't need it. Okay. And with that, all the members have been created perfectly. Fine. No issues. Now, the last part is that we need to define the actual floor roof tiles onto this particular face in order to complete this. Okay, so let's just do that perfect quickly. And for that, I'm just going to use a different template file of Revit, where I'm just going to say the file, new, and go to family, and just change this to family templates and English Imperial, and just change it to curtain panel pattern base. And we are going to use a pattern based family for this. Okay, fine. So I'm just going to change this size to, let's say, 15 inches across 1 foot. Okay, fine. And from here, now what I'm going to do is that I guess that this should be 1 feet and this should be 15 inches. Okay, perfect. Now I'm just going to select this particular set plane and set work plane, and I'm just going to select this plane associated to this point, this adaptive points. Okay, and just go to front elevation. Okay, and say that model lines, and click to the center and click this center arc and radius. Not that, this one, center and arc, and click to center, expand, and just click 3.25 inch. Okay, and then now three and a half, and come to this point and draw all the way to this point. Okay, so that arc has been created. Fine. Now one another, again click that same, and if the radius of this is how much, 3.5, so this should be, click this center and 3.25, 3/1/4 of an inch, and click this point, center and arc, and 3/1/4, come all the way down till here and then draw it. Okay, fine. Now what I'm going to do is that I'm just going to select this, or let's first draw the horizontal lines. Okay, so I'm going to draw a line and that same work plane from here to here, just come up 0.25 inch, and then join it. Okay, and I'm going to use this particular split element tool and split both these lines, and join this to this and join this to this. Okay, and yes, and with this I'm just going to select this entire element and move it, let's say 1 inch. Okay, and that would be 1 inch high. Okay, now what we are going to do is that we are going to create the same section with some different dimensions, but on this work plane. Fine. So what I'm going to do is that set work plane, and now this time this should be the work plane. Okay, and then again go to front elevation, and this time what I'm going to do is that center and arc, click snap to the center, but go only 3.14, 3.25, 3.25. Okay, click snap to center, and let's say that 2/3/4. No, 2/3/4 would be too less. It should be 3.5. And okay, let's create 3.5, and then complete it. Okay, and select this and change this to 3.25. Okay, perfect. And then one more, and that should be exactly 3. You will not follow right now what I'm doing, but once I complete this exercise, then you will get to know that what was the purpose of doing this. and just, oh, created on the wrong face, and 3, and just drop, and yes, okay. And now this same lines, 1 to 2, and 1/4 inch, and thus join them. Okay, and with this split elements tool, just 1 and 2, and join this, and join elements, yes, but I guess that we need to split it, and see it left, so it doesn't matter. Create one more line over here from this point to this point, okay. And that entire element has been created. What we just need to do is that select this and go to top and move it with constraint unchecked and disjoint checked. Just move it 1.5 inch, okay. And with that, select this both and just create form. Fine. So now, do you understand the purpose of creating these two different cross sections? The reason being that I wanted to create this style in a such a way that when it overlaps in the project environment, it should have this overlapping volumes. So when you have a water runoff, the water doesn't penetrates in. Okay. So the cross section on this side is larger and this is smaller. And also it has been given a displacement of 1.5 inch. Okay. So this was the purpose. Now what we just need to do is that select this entire chunk and material, just create one material, roof tiles material. Okay. And we don't have that. So we need to create one. So duplicate and just call it roof tiles material. And we will change it directly in the project environment. But right now I have just assigned that. And also now this family 1. Now we have to load that in this particular project 2. Okay. So I will just load that into the project. And herein, now if you just go to this curtain panels, then that family 1 has been loaded. Okay. And I'll just rename this and call it roof tiles. And also rename this roof tiles. Okay. And if you just go to type properties, then you see that the material parameter didn't pop up. Let's go to the, let's delete this because it's loaded in the project environment. So we don't need it anymore. And then right click this and edit it. Roof tiles and edit it. Okay. And we have created this roof tiles material. Yeah. So why didn't it appear here? Sorry. Absolutely sorry. I'm supposed to select this button, not that button, but this button and create a parameter. Fine. Sorry. And that should be roof tiles material. Because we are not defining that parameter here, we are just passing on that. So now this type properties will have that roof tiles material parameter, which is our material parameter. And just load that back into the project, override existing version. Sorry. And now if you just go to type properties, then you have this roof tile material, which you can assign a material actually. But before that, I would just like to close this and go to 3D of this. Fine. And now we are just going to perform the last step, which is the most important part of this particular exercise, wherein I'm just going to select this particular roof press tab until you find this 12-inch generic roof and this HI. Okay, fine. And now what I'm going to do is that I'm just going to go to massing and site, and we are going to create a mass which we are going to manipulate in such a way so we can lay the roof tiles properly. Okay, and onto this I'm just going to say that in place mass. Okay, and just call it roof tiles, and the family with this name already exists. You don't want to specify a different name. Yes, so let's say that roof tiles mass file. Okay, and then set plane, and very important step. Now again, you have to select this top plane. Okay, and with that selected, just draw 4 lines. 1, 2, 3, 4, and yeah, done. And with that mask selected, just create form solid form. So it will by default select this value, just change it to 1 inch. That's enough. And go to section 1. And with that created on this face, on the top of that particular roof, that 3D roof, just extend it and change its direction from here to here. Select this bottom part and snap it here. Okay, and now go to 3D, and with that selected CC, just press tab until you select this topmost part, and then just divide surface. Fine, and with that divide surface, now you enter the value that you have defined in that template file, that is 1 feet cross 15 inches. Okay, that is the value. 1 feet by 15 inches was the value that we used to design that roof tile in template file. Okay, and with that, now just drop this down. And when you drop down, you see that under rectangular pattern, you have your roof tiles perfectly positioned. And with that, you see that your roof tile has been laid. I guess that this distance was supposed to be. Now there are a couple of trial and errors guessing games. Yeah, see, and with this, the roof tile has been perfectly laid following that slope and that gradient and that face selected. Okay, we again need to make some changes. Beginning, and yeah, see. So we will have a full tile at this portion, and for this ridge member, we will have a cut tile. Anyways, this portion is going to get high. Okay, fine, perfect. And now if we just select this, and if I just go to edit type, then you can assign it a material, roof tile material, and let's define a material for that, wherein I'm just going to change this to this color, and yes, and also apply a bump. Okay, and the bump pattern should follow C and program files, common files, Autodesk shared, materials, textures, and one. And this is the path. And if you have properly extracted your library, then you will find this mats, this different textures that are provided by Revit. And from this, I'll select this image, which will provide a bump and to look like some glossy surface. Change this amount to a little bit, apply and OK, apply and OK. And with that, now if I just press R enter, that is realistic, then you see that your roof tile has been created. Okay, fine. This color seems a little bit eye-catching. So what we can just do is that define a different color, apply, OK, and yes. Yeah, this looks better. Fine. And you can see that it exactly appears like. But what important is that now if you just go to section, then you see that when you have a water runoff on this, then the water won't penetrate and you have the overlapping volumes. And we have perfectly achieved this particular thing. Where is it? Yeah, see, somewhat like this, wherein you have this overlapping volumes here too and in vertical segment also. Okay, so this is how you design the roof tiles, which was the main purpose of this particular exercise. And finally, now the ridge tiles. Okay, the ridge member and the valley rafter tiles, which is actually this one, and that we are going to create a slightly using different template file and different method. The method will be same, but the template file will be a little bit slightly different. Okay, wherein I'm just going to go to file and new, and this time I'm just going to go to family templates and list and English Imperial, and this time I'm just going to use this generic model, this template file, and open up. Okay, and herein I'm just going to define a reference plane 1 and 2, and this is going to be 15 inches again. Yeah, that's fine. And this is going to be only 1 feet, not even 1 feet. I don't exactly remember that. Let me just open up this, edit family, select this single tile, edit family, and reference level, tile depth and tile width is 8 inch only. Okay, fine. So sometimes even I need reference tile depth and tile width. So that's fine. Okay, and where is that? Uh-oh. Oh, this is not that file. Yeah, this is that file. Okay. So this is going to be a parameter, which I'm just going to call it tile depth. And this is going to one parameter. This is going to be tile width. Okay. And this is just going to be 8 inches. Now, what I'm going to do is that define a two cross sections here too. Just like we did for that particular template file, we need to repeat that process here too. Okay. And it by default opened up this four views, but that's okay. I'll just go to create and set and pick a plane, and this should be the work plane. Now let's define one section so we can just reference that particular thing across that section and section 1. And now what I'm going to do is that again I'm going to create simple model lines. No, this time I'm going to create a blend. Okay, blend. So that blend with that audit bottom type, I'm just going to use this, and I don't have anything to reference, so I'll just draw one simple line and then say that create and modify blend, and this center and arc I'm going to create. Okay, and this offset at 0.25. Okay, and li, we shouldn't have deleted that line. Anyways, split element and join this to this and this to this. And herein we will have a slightly different section for the top. So now I'll say that edit top, and again this should have a smaller cross section, wherein I'm just going to define this. Yes, created on the wrong side. Center and arc, center, and this too. Or why is it doing? Yes, okay, and offset it 0.25 and li and split element We are just using the drafting skills with Revit. Okay. And with that, I'll just finish this. Okay. And if I just go to 3D, then you see that that particular tile has been created with bigger radius on this side, I guess. Oh, it has snapped to wrong plane. So this should actually be, yes, 15 inches. And now you see that we have larger radius here and smaller radius here. Fine. So now what I'm going to do is that I'm just going to use a different template file for this new and family. And this should be family templates and English Imperial and generic model line base family. Yeah. And open it. And before loading that particular generic file into that, I will just like to assign a material parameter, wherein not this mistake that we made last time, associate family parameter and create new parameter. And this would be ridge tile material. Okay. And just okay, fine. And then load it into this family 3. So load and load it into family 3. Okay. And with that, now just come to this and delete this particular file. Okay. And just expand this generic models and call it rename ridge tile. The purpose of renaming is that you need, whenever you need any modifications and you need any changes, you can easily find that. Okay. Rename ridge tile. Okay. And then just drag and drop, press tab until you snap here. Okay. And what you need to do is that now just align, place this center point here. Let me make sure. Yes. Okay. And then just align this to this and lock. Okay. And herein, create one reference plane and create a parameter. What would be that? That would be mm, tile width. Yeah. Tile depth, I guess. Tile depth. Yes. And if you remember, then this particular thing has one type parameter, which is tile depth. Tile width, we don't need to pass on, but tile depth, I'll make it equal to tile depth, apply and OK. Fine. So that will snap and just change it to 15 inches and align and lock this. OK. Now we need to create one more parameter, and that would be buffer. Two more parameters, buffer. And buffer is that we need to create that in order, because we are going to have overlapping volumes for that. Fine. So herein, I'm just going to create one integer parameter, and that would be number of tiles, and that would be integer. Okay. And group it under constraints. Fine. Okay. So what would be that particular integer parameter? For that, one more parameter I need to define is that which should be actually this equal to length. Let me just try whether I can use those type parameters in this instance formulas. So number of tiles should be equal to overall length, which is the instance parameter, divided by tile depth. Yes, and yes, that's fine. Apply. See, this is what happens. So what I need to do is that first is that I need to create RP, one parameter over here, and that should actually be equal to buffer. Oh, it got deleted. Fine. Buffer, and that buffer should be only 1.5 because you're going to have overlapping volumes of 1.5 inch. Okay. And just as this length, we need to create one more parameter that would be tile number of tiles, let's say. No, number of tiles is that integer we are going to create. Tile width, just a parameter. But that would be type parameter and not instance parameter. And that should be same as this length. Okay. So now I'm just going to go to type and just define an integer parameter, number of tiles, and that should the data type should be integer. Okay. And I would like to group it under constraints. Okay. And that number of tiles should be now tile width divided by tile width divided by what? Tile depth. Yes, tile width divided by tile depth. Okay, and just click OK. But with this, I'm just going to select this and create an array and click this point and snap it to this buffer. Okay. The reason being that we want this overlapping volumes, and that should be equal to number of tiles. No. Again, I need to check once. This is really, and this edit. Oh, sorry. Go to 3D, and you see that this is the very difficult and there are a lot of steps. So sometimes I keep forgetting the steps. So I need to have that reference file always open. Tile depth should be 15 and that should length divided by buffer. Oh, okay, fine. Buffer. Yes. So just delete this and yeah. So there is no need of the buffer parameter here. Tile width divided by buffer. And that buffer should be 1 feet 1.5, not 1.5. Okay, and just apply and okay. Fine. Sorry guys, I just forgot. So that's why. Now, first says that this is already a group, so ungroup it and select this and say that array and select this point and say that to last, and with group and associate, just pick this. Okay, and with that, now when you select, first is that you need to align this face and lock it, and when then select this and just change it to number of tiles. Perfect. And now when you expand this, it will properly expand. Okay, with that buffer of 1 feet 1.5, and the tile width is 1 foot 50. Okay, with this, now this family 3, I don't need this, so just close it. It has this rich tile, and again I need to go to type properties of this and associate this parameter in this rich tile material, and OK and OK. Fine. So now this template file has this rich tile material. Okay. And now pass on this family 3 into the project environment. What is family 2? Yes, this was not needed. And load it into the project environment. And you cannot place it just like that. But what you need to do is that just turn on HR and finish mass. And you see that I will select this particular valley rafter. This was not supposed to be valley rafter. This was supposed to be ridge member, ridge board. Yes. and it's a justification to bottom. And yes, then why is it not appearing properly? Section 1, yes, and ridge board, and it's that justification to bottom, and this 18 inches. Fine. So even 18 inches is less. So that was just, and even that is not enough. And 24 inch 2 feet. Okay. And that would be enough, I guess. Yeah. Okay. That is just the ridge board, and that might have removed the notching. So again, we need to select this 1, 2, 3, 4, 5, and 6 HI and isolate that and have a perfect join condition. This is really time consuming, guys. Yes, and here too. Yes, okay. Okay, and now the notching has also been applied and it's perfect. Valley rafter. Yeah, absolutely perfect. Okay. And now what we just need to do is that HR, and also the width of this valley rafter needs to be, the depth of this needs to be increased. Okay. So edit type and rename this and call that 24-inch ridge board. Okay, fine. But this valley rafters, edit type, and let's try 21-inch for this. Apply. Yeah, that's perfect. Just rename it 21-inch. Okay, and fine. And now with this, what I'm going to do is that the generic models would have that family 3. I'm just going to rename this and call this line based roof tiles. Copy and rename and copy it here as well, and it would have the material parameter which needs to be passed on, or not passed on, we can just create one. And this roof tile material I will just duplicate and asset, and here too I will just duplicate this as well, and from here I'll just change this color to something different. Okay, and apply and okay, and apply and okay, and I'll just drag this. And see, it has two options, that place on face, place on work plane. You can select any one of them. I'm just going to select this place on face. And you see that blue line pops up showing that face. So I'm just going to drag from here to this point. And you see there might be some problem for this particular family, edit family. Let me check what it was. Tile depth is fine. So see, here it is expanding. See, here it is perfect. Then why is it not? Rabbit sometimes behave really weird. Let's try it the other way around, wherein I'm just going to drag this and place on work plane. And for that, I'm just going to pick a plane, pick this plane, and then the roof tiles, place on work plane. And 1, 2, no, it is still creating a problem. So I actually need to check this. Let's check it in that file. This is the tile width, CC, template file, length by buffer, and buffer is 1 feet 1.5, and tile depth is 1 feet 15. wireframe. Yes. So the same step we have did here, but I don't know that why is it. Yeah, okay. Actually, I suppose that this was not supposed to be created. Tile width. So let's just delete that parameter, but we cannot delete it. First is that we need to assign this. And in order to make assign this length, which is an instance parameter, I need to change this to instance as well. And from here, tile width, I'll remove and make it equal length divided by tile depth. Divided by buffer, not tile depth. Sorry. Okay. And just get rid of this parameter. We don't need it. Apply and OK. Fine. And with all this changes, let's just load that back into the project. Okay. Overwrite existing version. And yeah, see. So sometimes things, see, the problem was that, see, I'll just make you explain. See, this length is going to be an instance parameter. Instance parameter because Revit doesn't know that where we are going to snap those tiles onto. So instance parameter because it has to instantly adapt to that face length in this particular file. So one step I forgot was that I unnecessarily created that tile width and I don't know what process was going in my head at that particular time. But actually I was supposed to keep this both instance parameter, okay, and use this length. So that was the only problem. Fine. So with that, now if I select this SA and HI, if I just go to component, then it's line based styles and place on work plane. But essentially you need to set the work plane or you can just place it on face also. Now there won't be any problem. So line based component and line based roof tile and place on face and select this face. No, it is not working that way. So place on face, pick a plane, place on work plane, and then component and select from this point to this point. Architecture, set, pick a plane, select this plane, component, snap it from here to this face. Likewise, architecture, set, pick a plane, and component, select this and architecture and set and pick a plane. This plane, SH or HL, component, and snap from this point to this point. Okay, and with that, turn it to realistic HR, and you see that it has been perfectly created. Okay, only thing is remaining is this particular roof. What I need to do is that I need a fascia board over here. Okay, so again, I need to go to roof and say that fascia, and I'm just going to click this line. Okay, and that fascia board occurs, but that is right now this direction. Let's apply it on this face as well. Fascia, and yes, okay, and I'll select both of them, or let's individually select them, and you see that it has this arrows, flip arrows, which you can just flip. Okay, and herein what you can do is that apply a material to that also. I'm just going to use an existing material, apply and okay. And then what you can do is that adjust the height. This is right now referencing this profile fascia 1x12. So you need to go to profile section and fascia flat. Just drop this down, type properties and duplicate this and call it 1 cross 15, wherein the thickness, I'm just going to say that 1 inch, and the height should be 15 inches, or let's say 18 inches, and rename 1 inch cross 18 inches. Okay. And now in that file, just go to edit type and duplicate this and call this 1 cross 15 or 18. Okay. And onto that, reference the profile that we just edited and made this flat 1 cross 18 inches. Okay. Apply and okay. Fine. So that is pretty much perfect. Also change this to 1 cross 18. Sorry, not that. Yeah, 1 cross 18. Fine. And now onto this, we have to apply this. So let's apply this. I suppose that 1 cross 18 was too much. So let's go to this type properties and make it not 18 inches, but let's make it 16 inches. I'm not renaming it right now. You just rename it. Okay. And then we can see the edge. Okay. And then go to roof and gutter and just apply it. Okay. And herein, I'm just going to change this material to something. Yeah, that's fine. Apply and okay. And just change it to R enter. Yeah, fine. So this is how you do the modeling part in Revit. Okay. The last step remaining is for this particular thing, wherein I'm just going to use this particular family and not detailed out, is that this is also a line based family, which is a custom fascia. I'll just edit this particular family and save it on desktop so we can use it. Save and just close it. And herein, I'll just open it and go to desktop. And where is that? We just saved it. Yeah, custom fascia, and just open it. And that is also a line based family. And just load it into the project. And with that, I'll just go to 3D. And herein, under generic models, or let's say that component, we have that custom fascia and place on work plane, or let's say place on face. But place on face is not working. I don't know why. Let's say that just drag and yeah, place on face. And with that, this face selected, HL, with this face selected, just drag it from here to this end. And with this face selected, let's drag it from here to here. Okay. And just R enter. Fine. So we have perfectly created that. If you want to change the position of that decorative fascia element, then just go to any of the section, and herein you can just give it a offset of, let's say, something like 6 inches. No, move and disjoin and just change it to 4 inches. Yeah, fine. And likewise in this section also, move and move it 4 inches. Okay. And let's go to 3D. And you see that that particular thing has been perfectly created. Okay. Now creating this, I just I just say loaded it from different file because I didn't want it to waste time. But this is very simple. You just go to edit family of this. Then you see that this is also a line based family. Line based families are the one that we created using a generic model and then loading that particular generic model into the line based template file. It is that particular same process. Okay, if you just go to reference plan and you see that this is again a line-based family which has this instance parameter length. Okay, and that the number of elements length by spacing. Okay, and that same methodology has been used, and this is just a generic file fascia which the extrusion has been created. See, going to reference level and giving it a spacing, and this is nothing but just a simple extrusion. See, extrusion start 0 and extrusion end half inch. Okay, so this is just an extrusion. You can design whatever you want, but important is that after designing that particular decorative fascia element in generic model, you need to load it into this line line based family and then multiply it, and then once that family is created, you have to load it into the project environment and make it face based element. Okay, and you can snap it. Okay, and now if you just go to this particular section and you see that it perfectly appears. Fine. So this particular thing has been achieved. Okay, only thing is left for this file is that I want to show you that how can you create a truss member for this particular roof. Okay, and this same process follows entirely for creating this particular custom roof. Okay, and the same method has been followed, and you see that selecting that particular work plane, that glitch of that roof tile not reaching this rig board has been rectified. Okay, so there is no rocket science in creating this particular thing. Fine. So I'm just going to quickly show you that how can you create the truss member which follows the slope of the roof. Fine. So again, I'm just going to go to level 1 and architecture and roof by footprints, place at level 2, and with overhang of 2 feet. I'm just going to create one simple roof, but this time this is going to be gable roof. So I just select both of this and uncheck define slope and just create that. Okay, fine. So the modeling of this elements remains the same for this. Okay, only thing is that how to lay the truss members on this part, how to create a truss members following this slope. So that is very simple. You just need to go to structure and truss. And right now, no structural truss is loaded in the project. Would you like to load one? Yes. I would just go to this same path, RE 2024 libraries, English Imperial US. And under that, instead of structural framing, this time I will select structural trusses. And herein, I have the simple 6 panel, a lot of trusses, but I'm just going to select this one and the work plane at level 2. And I'm just going to select this point and this point. Okay, and that truss has been created. If you just see that, okay, what you just need to do is that you again need to create the members of this truss, which right now it has been by default selected this rafters. Okay, so herein I'm just going to go to this timber and define two more. One of them will be, I will just duplicate this because we are going to use that same size, type properties and duplicate, and call this truss web members. Okay, and okay, and another is going to be this perlins, wall plates, what, yes, wall plates, and just type properties and duplicate this and call it truss top bottom chord. Okay, and with that I'm just going to click OK. Fine, and now while in this, I'm just going to press tab and select this, okay, uh, top bottom chord, yeah, fine. And for this, I'm just going to select the same top bottom chord. And for all of this, 1 and Actually, I can edit this particular truss system only. Yeah, so how stupid. Sorry. So herein, for top chords, I'm just going to set the framing type to be this top bottom chord that we selected, and the vertical webs to be the truss web members, and the diagonal webs also to be the web member. Sorry, where are you? Yeah, web member, and bottom chord to be also the same, this truss top bottom chord, and just apply and okay, fine. So that will do the job. Okay. Okay. And with that, now you need to adjust this height. So if I just select this particular truss, let me just change to wireframe. And if I just select this particular truss, then you see that the bottom chord is the member which is going slightly getting inserted in the wall. But if I just select this, then if I just drop down, then you see that the truss height 6 feet. So where is it reading 6 feet from? So it is reading that 6 feet from center of this to center of this. Fine. So in order to align this properly, what I'm going to do is that first I'm just going to move, and with constraint unchecked, I'm just going to move it one. Okay. And now what you need to infer is that what should be the height of the truss member entered in order to match this profile. So in order to do that, I'll just measure this. Let me just hide this. Uh-oh. Let me just hide all of this and say that what is the distance? This is 9 foot 3 inches. Fine, 9 foot 3 inches. So HR. Now, as I just made you explain that this is snapping to center of this and center of this, which height it is reading. Now, the height of this is 9 foot 8 inches, and this is 3 inches. Okay. And also from center of this is 3 inches. So what we need to do, we need to compute this height in a such a way that we will deduct 3 inches from top and bottom, and what remains will be the height of the truss that will properly position this particular truss. Okay. So what we need to do, 9 foot 8 foot 9 inches nahi hai. How much it is? H and 9 foot 3 inches. Fine. So 9 foot 3 inches minus 3 inches is 9 foot. So let's just try first. 9 foot. Yes. Okay. Perfect. And now it is following the slope. See, what we just need to do is that select this and M enter, and with this join check, just move it from this point to this point and pin it again. Okay. And move, and with this join checked, just move it from this point to this point and pin it again. Fine. And with this, now you have your perfect truss member following this roof slope, and rest everything remains the same. Okay. Clear, everybody? Fine. Now, what my point is that I'll just take you to this particular file. And this file has the truss member completely different. See, this particular truss has only the top chord and the bottom chord. But this truss has the top chord and this extra bottom chord, which is not present in that file. If I just select this and go to edit family, then there are no vertical bottom chords. There are no vertical members over here. Fine. So in order to achieve that, this particular thing, what we need to do is that we need to, I will just drop this down, and I have already edited that truss system. And where is it? Structural trusses, and go to this PTS truss and just expand it and edit it. So that will open up the template file. So depending upon the gradient of your roof, you have to design this particular truss system in its template file. You have to edit, and lay the reference plane and give the heights and constrain it. Fine. And with that, when you load that into the project environment, it will accept that height. Fine. So that is how that particular truss system has been designed. And if I just go to level 1, and if I just take you to this particular horizontal section, then you see that CC, and this is the roof. This is the roof, and this is the truss, which is exactly following that particular slope. And that is how that truss member is laid here. Okay, fine. So watch this video and get up to this point, and you will be provided with this particular practice file, and the link will be in the description. Don't worry. Okay, and just practice and get up to this point, and let me know if you have any doubts or queries in the comment section. And if you think that this video was worth, then kindly enroll for this course, and let's learn together and let's grow together. Bye.